There's something almost mythical about the pumpkin. Every autumn, it appears in fields across America like clockwork, transforming landscapes into seas of orange. We carve them, we decorate with them, we celebrate them. But here's what most people never consider: that creamy, perfectly spiced pumpkin pie you devour every Thanksgiving? It didn't come from the jack-o'-lanterns sitting on your porch. In fact, the pumpkins destined for your pie filling live an entirely different life, one hidden inside massive industrial facilities where science, agriculture, and precision engineering converge in ways you've probably never imagined. This isn't about a quaint farm with a rustic barn. This is about a high-tech operation processing millions of pounds of pumpkins annually, transforming raw gourds into the smooth, consistent filling that defines an American tradition. What you're about to discover will change how you see that innocent can in your pantry forever. Most people assume all pumpkins are created equal. They are not. The pumpkins grown specifically for pie filling are an entirely different breed, cultivated not for size or appearance, but for flavor density, sugar content, and flesh consistency. These aren't the massive, hollow specimens you see at pumpkin patches. These are compact, heavy, thick-walled varieties with names like Dickinson Field or Libby Select, bred over decades to maximize the qualities that matter when you're creating a product consumed by millions. The average pie pumpkin weighs between 10 and 20 pounds, but what's inside is what counts: dense, sweet flesh with minimal water content and a naturally smooth texture that requires less processing. Here's the kicker: these pumpkins are so specialized that most consumers have never seen one in person. They're grown on contract farms, harvested mechanically, and transported directly to processing facilities without ever touching a retail shelf. The harvest itself is a spectacle of modern agriculture. Picture this: fields stretching for hundreds of acres, planted in precise rows calculated down to the inch for optimal sunlight exposure and equipment access. When the pumpkins reach peak ripeness, usually in September and October, massive mechanical harvesters roll through the fields like something from a science fiction film. These machines don't gently pluck pumpkins. They cut the vines, lift the gourds onto conveyor systems, and separate them from debris in a single continuous motion. A skilled operator can harvest several acres per hour, collecting thousands of pumpkins that will eventually become millions of cans of pie filling. But here's what's fascinating: timing is everything. Harvest too early, and the sugar content is insufficient. Wait too long, and the flesh becomes stringy and loses its ideal texture. Farmers use a combination of experience, field sampling, and even spectrometric analysis to determine the precise moment when an entire field should be harvested. Once harvested, the pumpkins begin a journey that would surprise most people. They're not immediately processed. Instead, they undergo a curing period where they're stored in climate-controlled environments that allow the starches to convert into sugars, deepening the flavor and improving the texture. This is agricultural alchemy at work, a process that takes patience and precision. The storage facilities maintain specific temperature and humidity levels, creating conditions that enhance the pumpkin's natural qualities without allowing spoilage. Some facilities can store millions of pounds of pumpkins, ensuring a year-round supply of pie filling even though the harvest happens only once annually. Think about that. The pumpkin pie you eat in July came from a gourd that was likely harvested the previous autumn and has been carefully preserved through sophisticated storage techniques. Now here's where it gets truly industrial. When pumpkins are ready for processing, they're transported to facilities that look nothing like what you'd imagine. These aren't charming canneries with workers in aprons stirring giant pots. These are state-of-the-art food processing plants where automation, quality control, and food safety protocols operate at levels that would impress a pharmaceutical manufacturer. The buildings themselves are massive, often covering several football fields, with specialized zones for receiving, washing, cooking, processing, canning, and storage. The air inside is controlled, the water is filtered, and every surface that touches food is made from materials that meet strict FDA standards. This is food production at an industrial scale, where a single facility can process tens of millions of pounds of pumpkins in a single season. But before we dive into the machinery and processes, let's talk about something most people never consider: waste. Or rather, the lack of it. Modern pumpkin processing facilities operate with near-zero waste principles that would make environmentalists weep with joy. The seeds are separated and sold to snack food manufacturers or pressed for oil. The fibrous strands are processed into animal feed or composted. Even the rinds, which contain valuable nutrients, are repurposed. Some facilities have developed methods to extract pectin from pumpkin waste, selling it to companies that make jams and jellies. Others use anaerobic digesters to convert organic waste into biogas that powers portions of the facility itself. This isn't just good environmental practice, it's smart economics. When you're processing millions of pounds of pumpkins, even small percentages of waste represent enormous volumes and lost revenue. The quality control begins long before the pumpkins enter the facility. Incoming loads are sampled and tested for sugar content, moisture levels, and potential contaminants. Pumpkins that don't meet specifications are rejected entirely. This might seem harsh, but consistency is everything in food manufacturing. A single batch of substandard pumpkins could affect thousands of cans, potentially impacting brand reputation and consumer trust. The testing equipment used is remarkably sophisticated. Near-infrared spectrometers can analyze the internal composition of a pumpkin without cutting it open, measuring sugar content, fiber density, and moisture levels in seconds. This technology, originally developed for other industries, has been adapted to ensure that only the finest pumpkins make it to the production line. Here's something that might blow your mind. The color of pumpkin pie filling is carefully controlled and standardized. Natural pumpkins vary in color depending on variety, growing conditions, and ripeness. But consumers expect a specific shade of orange when they open a can of pie filling. To achieve this consistency, processors blend different varieties and batches, using colorimeters to measure and match exact color specifications. It's not about adding artificial coloring, it's about creating consistent blends from natural variations. This level of precision extends to every aspect of the product: texture, sweetness, moisture content, even the subtle flavor notes that make one brand different from another. The science behind creating a consistent product from an agricultural commodity that varies naturally is genuinely impressive. And speaking of science, let's talk about something most people never think about: the spices. That warm, comforting flavor you associate with pumpkin pie. It's not primarily the pumpkin. It's the blend of cinnamon, ginger, nutmeg, cloves, and sometimes allspice that creates the signature taste. Interestingly, many processing facilities produce both plain pumpkin puree and pre-spiced pie filling, and the difference in manufacturing complexity is significant. The spice blends themselves are proprietary formulas developed and refined over decades, mixed in precise ratios that are trade secrets. The spices are sourced globally, tested for quality and purity, and blended in dedicated facilities before being added to the pumpkin base. Some manufacturers use microencapsulation technology to protect volatile flavor compounds, ensuring that the spices taste as fresh when you open the can months later as they did when first blended. The shelf life of canned pumpkin is another marvel of food science. Properly processed and sealed, canned pumpkin can remain safe and flavorful for years. This isn't because of preservatives, it's because of the canning process itself, which creates a sterile, anaerobic environment where spoilage organisms cannot survive. The combination of heat treatment, pH control, and hermetic sealing creates a product that's essentially frozen in time from a microbiological standpoint. This is why you can buy pumpkin pie filling in July and use it in November without any degradation in quality. The technology behind this is over a century old in principle, but modern facilities have refined it to extraordinary levels of precision and safety. Now, here's a question that might have occurred to you: why canned? In an era of fresh, local, and organic, why does pumpkin pie filling remain predominantly a canned product? The answer is multifaceted. First, convenience. Making pumpkin puree from scratch is time-consuming and messy. Second, consistency. Home-processed pumpkin varies wildly in moisture content and texture, making reliable baking difficult. Third, availability. Fresh pie pumpkins are seasonal, but the desire for pumpkin pie is year-round. Fourth, and perhaps most importantly, safety. properly canned pumpkin is microbiologically stable in ways that home-processed versions often aren't. The canning process, when done correctly at industrial scale, creates a product that's actually superior in many ways to what most home cooks could produce. If you like this kind of content, make sure to subscribe to the channel and hit that like button. We are taking you inside the factories and facilities that produce the everyday products you never think twice about, revealing the incredible engineering and processes that make modern life possible. Now, let's step inside the facility itself and see exactly how raw pumpkins become the smooth, consistent pie filling you know. The process is more complex and fascinating than you might imagine, involving multiple stages of washing, cooking, processing, and quality control, all orchestrated with precision timing and rigorous standards. The journey begins at the receiving dock, where truckloads of pumpkins arrive throughout the harvest season. These aren't random deliveries. They're scheduled based on the facility's processing capacity and storage availability. Each load is documented, sampled, and inspected before being accepted. The pumpkins are typically delivered in large bulk containers or directly in truck beds, having been mechanically harvested and field sorted. Upon arrival, they're weighed, and samples are taken for laboratory analysis. This initial quality check is critical. It determines whether the load meets specifications and, if accepted, how it will be blended with other batches to achieve target product characteristics. Once accepted, the pumpkins are conveyed into the facility through receiving systems that can handle enormous volumes. We are talking about conveyor systems capable of moving tens of thousands of pounds per hour, built to handle the irregular shapes and weights of whole pumpkins without damage. The pumpkins travel through an initial inspection station where workers remove any that show signs of damage, disease, or foreign material. This manual inspection, despite all the automation in modern facilities, remains important because human eyes can spot issues that machines might miss. The first major processing step is washing, and this isn't a gentle rinse. The pumpkins pass through multiple washing stations using combinations of water sprays, brushes, and agitation to remove field dirt, debris, and surface contaminants. The washing systems use filtered, chlorinated water at controlled temperatures and pH levels to ensure effective cleaning while meeting food safety standards. The water is recirculated and treated, with fresh water continuously added and wastewater removed for treatment. Some facilities use ozone or other advanced sanitizing systems to ensure that surface pathogens are eliminated. The pumpkins emerge from the washing system clean enough that they could theoretically be processed without further treatment, though of course, additional steps follow. After washing, the pumpkins move to the cutting and deasting operation. In modern facilities, this is often partially automated, with machines that can orient pumpkins, cut them into halves or quarters, and extract the seeds and fibrous material in continuous operations. However, many facilities still employ workers for this stage because the variability in pumpkin size and shape makes full automation challenging. The workers use specialized cutting tools and work at ergonomically designed stations, processing pumpkins at impressive speeds. The seeds and fiber are conveyed away separately for processing into byproducts, while the cut pumpkin pieces continue to the next stage. Here's where it gets really interesting: the cooking process. The pumpkin pieces are conveyed into massive steam cookers, essentially giant pressure vessels where they're subjected to precisely controlled heat and pressure. This isn't like cooking pumpkin in your kitchen oven. These are industrial-scale continuous or batch cookers operating at temperatures and pressures calculated to achieve specific outcomes, breaking down cell walls, gelatinizing starches, concentrating flavors, and achieving the texture that will allow for smooth processing. The cooking time and temperature are critical variables, carefully controlled and monitored. Too little cooking, and the pumpkin won't process smoothly. Too much, and you get caramelization and flavor changes that aren't desirable in pie filling. The cooked pumpkin emerges from these cookers transformed, soft, aromatic, and ready for the next critical step. The pieces are conveyed to separation equipment that removes the rind and any remaining seeds or fiber. This equipment uses a combination of mechanical action and screening to separate the usable flesh from waste material. The efficiency of this separation is remarkable. Modern systems can recover over 95% of the usable pumpkin flesh, leaving behind only the tough outer skin and any fibrous material that escaped earlier removal. The separated pumpkin flesh then moves to the refining stage, where it's transformed from cooked pumpkin pieces into the smooth puree you recognize. This involves passing the material through finishers or refiners, essentially sophisticated screening and grinding equipment that reduces particle size and creates a uniform texture. The degree of refining can be adjusted based on the desired final product characteristics. Some products are refined to an extremely smooth consistency, while others retain a slightly coarser texture. The refining process also provides another opportunity to remove any remaining undesirable material, small pieces of skin, fiber, or seeds that made it through earlier stages. The refined pumpkin puree at this stage is essentially the base product. For plain pumpkin puree, it proceeds directly to filling. For spiced pie filling, it moves to blending tanks where the proprietary spice mixtures, sweeteners, and other ingredients are added. These blending operations are precisely controlled, with ingredients added in specific sequences and mixed for calculated durations to ensure complete incorporation and uniform distribution. The blending tanks are jacketed vessels that can heat or cool the product as needed, and they're equipped with agitation systems designed to handle the viscous pumpkin mixture without incorporating excessive air. Quality control during processing is continuous and multi-layered. Samples are taken at multiple points in the process and tested for various parameters: pH, viscosity, color, flavor, temperature, and microbial load. The testing is both automated, using inline sensors and analyzers, and manual, with laboratory technicians performing more detailed analyses. Any deviation from specifications triggers immediate investigation and, if necessary, adjustments to the process or rejection of the affected batch. This level of quality control is what ensures that every can of a particular brand tastes the same, whether you buy it in Maine or California, in October or April. The filling operation is where the processed pumpkin finally meets the cans that will carry it to consumers. Modern filling lines are marvels of precision engineering, capable of filling hundreds of cans per minute with exact weights. The cans themselves arrive at the facility pre-manufactured, usually in bulk shipments of millions at a time. They're stored, conveyed to the filling line, and positioned under filling heads that dispense precisely measured amounts of pumpkin. The filling equipment must handle the viscous, sometimes chunky nature of pumpkin products while maintaining accuracy and speed. After filling, the cans move immediately to seaming machines that apply and crimp the lids, creating the hermetic seal that's essential for shelf stability. But filling and sealing isn't the end of the process. The sealed cans must undergo thermal processing, essentially cooking in the can to ensure commercial sterility. This is done in retorts, large pressure vessels that can hold thousands of cans and subject them to precisely controlled heat and pressure cycles. The time and temperature are calculated based on the product formulation, can size, and desired shelf life, following protocols that have been validated through extensive testing. The retort process is perhaps the most critical food safety step in the entire operation, and it's heavily regulated and monitored. Every retort cycle is documented, with temperature and pressure charts that must be reviewed and approved before the product can be released. After retorting, the cans are cooled, again under controlled conditions to prevent thermal shock that could damage the cans or affect the product. The cooling water is chlorinated to prevent recontamination if any cans have microscopic seal defects. Once cooled, the cans are dried, labeled, and coded with production information including date, time, and batch codes that allow complete traceability. This coding is essential for quality management and, in the unlikely event of a problem, enables precise product recalls. The labeled cans then move to final inspection, where they're checked for defects, dents, improper seals, labeling errors, or other issues. This inspection combines automated systems that can detect certain defects at high speed with manual inspection for issues that require human judgment. Rejected cans are removed from a line, and the product is either reprocessed if possible or disposed of according to strict protocols. Approved cans are packed into cases, usually in groups of 12 or 24, and the cases are palletized for storage and shipping. The palletizing is typically automated, with robotic systems that can stack cases in precise patterns that maximize stability and space utilization. The completed pallets are wrapped in plastic film for protection and moved to warehouse storage. The warehouse itself is a critical part of the operation, maintaining conditions that preserve product quality until shipment. Temperature and humidity are controlled, and the warehouse management system tracks every pallet, knowing exactly what product it contains, when it was produced, and where it's located. This allows for first-in, first-out inventory management, ensuring that older product ships before newer product, and enables rapid response to customer orders. Throughout this entire process, from receiving raw pumpkins to shipping finished cans, the facility operates under food safety management systems like HACCP, which identify critical control points and ensure that monitoring and corrective actions are in place. The facility is regularly inspected by regulatory agencies and often by third-party auditors representing major customers. The documentation generated is extensive. Every batch, every process step, every quality check is recorded, creating a complete history that can be reviewed if questions arise. The scale of these operations is difficult to comprehend until you see it in person. A major pumpkin processing facility during peak season is processing millions of pounds of pumpkins per week, producing millions of cans, operating around the clock with multiple shifts. The coordination required to keep everything running smoothly, the raw materials flowing in, the finished product flowing out, the quality maintained, and the safety ensured, is genuinely impressive. The people who work in these facilities are skilled professionals, from the operators running complex processing equipment to the quality control technicians ensuring product safety, from the maintenance crews keeping everything running to the logistics coordinators managing the flow of materials. This isn't unskilled labor. It's specialized food manufacturing requiring training, attention to detail, and commitment to quality and safety. As we've seen, transforming pumpkins into pie filling is far more than just cooking and canning. It's a sophisticated industrial process combining agriculture, engineering, food science, and quality management to create a consistent, safe, shelf-stable product that millions of people enjoy. The next time you open a can of pumpkin pie filling, you'll know the remarkable journey it took to get there. Speaking of fascinating food production stories, have you ever wondered how bananas, one of the world's most popular fruits, are transformed into dried snacks and cakes? The process involves completely different challenges and technologies compared to pumpkin processing, from dealing with a highly perishable tropical fruit to creating products with extended shelf life. The banana processing industry has developed some truly innovative solutions to these challenges, including techniques for preventing browning, methods for achieving the perfect texture in dried products, and processes for creating consistent flavor in baked goods. The scale of banana processing is enormous, with facilities handling millions of pounds of fruit and producing everything from simple dried banana chips to complex cake products that appear on shelves worldwide. If you want to see inside a banana processing plant and discover how this tropical fruit is transformed into shelf-stable snacks and baked goods, that video just appeared on your screen. Trust me, you won't look at banana bread the same way again. And if you enjoyed this deep dive into pumpkin processing, make sure you are subscribed to the channel so you don't miss future episodes where we explore the hidden world of food manufacturing. Before you go, I'm curious, what surprised you most about how pumpkin pie filling is made? Was it the specialized pumpkin varieties, the scale of the processing facilities, the precision of the quality control, or something else entirely? Drop a comment and let me know. I read every one, and your feedback helps shape future episodes. Thanks for watching, and I'll see you inside the next factory.